Hello and welcome to this Hawk Hydromet webinar on satellite water quality monitoring. I'm Nick Rendell with Hawk Hydromet, and with me today is Jim Harpin, Business Development Manager with Blue Water Satellite. Throughout our 20-minute presentation, we will introduce Blue Water Satellite as a company, provide an overview of satellite water quality measurement technology, its measurement principles, and the parameters it covers, and also provide a demonstration of the GIS software. We will then briefly cover the proof of performance and using historical data to identify trends within our water body. Later, we will review the advantages of using satellites to monitor water quality and also outline how to best integrate satellite monitoring technology with spot sampling from HydroLab sondes. Finally, we will review the basic price structure of satellite imaging and show just how economical it can be. I will now provide a brief history of Blue Water Satellite. Blue Water Satellite was co-founded in 2007 by Dr. Robert K. Vincent, one of the world's leading experts on remote sensing and a professor of geology at Bowling Green State University. Dr. Vincent is co-founder and former director of OhioView, a remote sensing consortium of the 10 largest research universities in Ohio. In the past 5 years, Dr. Vincent has received over $1 million in NASA and NOAA grants to perform work on satellite monitoring of toxic algal blooms. Blue Water Satellite has received 1 U.S. patent for its measurement algorithms and currently has 4 pending. Its success has spread to the global market in the past few years with projects in North America, South America, Asia, and Australia. Hawk Hydromet has partnered with Blue Water Satellite to provide this advanced service to customers and help optimize their water quality monitoring programs in addition to current efforts with HydroLab sondes. Jim is now going to cover the Blue Water Satellite measurement principles in detail.
Well, good afternoon, everyone. Blue Water Satellite's imaging allows you, for the first time ever, to see the condition of your entire lake or other body of water. But our data also allows you to inspect the finest details. Now, what you're looking at here is a scan that we did for cyanobacteria, blue-green algae, in Wikiup Reservoir in the state of Oregon. With our data sets installed in your GIS software, that would be like ArcGIS, you can zoom into specific areas and see exact concentrations of cyanobacteria, chlorophyll A, and total phosphorus, the nutrient that feeds cyano and chlorophyll. And these are measured in parts per billion. That's billion with a B. How do we do it? Well, our system is based on the exact same principle as the spectrometers used by scientists for decades, detecting different bands of light in nanometers. What we do is we process raw data from 2 USGS satellites, Landsats 5 and 7. We run those through our patented and proprietary algorithms. What's enabled us to succeed is that our algorithms are based on the ratios between multiple bands of light versus just the raw reflective values. Each constituent, each parameter, has a very specific spectral fingerprint. It is the ratios between the bands of light that enables us to detect and measure these contaminants, regardless of what else is present in that body of water. Now, this is not cookie-cutter, one-size-fits-all technology. Before processing, our technicians first correct each Landsat frame for atmospheric conditions such as humidity, particulates, and ozone, using a method known as dark object correction. Also, the ratio basis of our algorithms corrects for sunlight reflection variances caused by waves and ripples, and clearly distinguishes what we're testing for from other substances in the water. This table presents a very conservative view of our ranges of accuracy. We actually have 2 separate algorithms for cyanobacteria and 2 for total phosphorus, both based on low and high concentrations. Now you can see that the margin of accuracy is higher in the higher concentration algorithms. You would only see those broader margins where the much higher concentrations of cyanobacteria or total phosphorus are present. Our technology has been under development since the year 2000, with the first patent issued in 2006. Since then, our technology has been rigorously tested and peer-reviewed with a number of academic papers published. Okay, let me show you here real quickly a couple of case studies of our work. This first table shows results of a total phosphorus correlation study conducted on Lake Travis in Texas. We did this with the Lower Colorado River Authority. We compared the samples they took from the lake within 30 minutes of Landsat satellite overpass. At one sample point, their results, done in a laboratory, showed 28 parts per billion of phosphorus, while blue water detected 24 parts per billion. At point 2, they were at 73 parts per billion. We detected 78 parts per billion. And at the third point, their lab testing showed 18 parts per billion, and we detected 17 parts per billion. These two regression analyses are combined data from correlation studies in Lake Washington, which is in the state of Washington, and Lake Champlain in the Northeast. And they point out that the closer the sample is taken to satellite overpass, so that we're actually comparing apples to apples, the closer our correlation gets. Samples taken within an hour of overpass give us an R-squared adjusted of 72%, but when we look at samples taken within 30 minutes of overpass, our accuracy increases to an R-squared adjusted of just under 85%. Now, one of the most unique values Blue Water Satellite brings is our ability to look back in time. Like these cyanobacteria scans of western Lake Erie over a 14-year period, we can help you detect precisely when your problems began and how quickly they developed. And conversely, we can help you track improvements resulting from remediation efforts. Blue Water Satellite can retrieve stored Landsat data as far back as 1984, running the old through our new algorithms. Really, a good comparison there is that it's similar to the way crime labs solve old cold cases with DNA testing that wasn't available when the crimes occurred. No other technology can test every body of water in an entire watershed in one fell swoop, and at the same time give you the condition of each and every small body of water. On the left there is a project we conducted for an environmental agency in Ontario. It's the Rideau Lakes region. There are 106 lakes in this frame, and we were able to show the clients exactly where they were having cyanobacteria problems, allowing them to deploy their resources directly to the trouble spots, saving them a tremendous amount of time and money. So you really have to ask yourself, would you have the wherewithal, human or financial, to test so many bodies in such a wide area? Some other advantages. Landsat 5 and 7, they cover every square inch of the Earth every 8 days. And in many areas, there's overlap, allowing new data every 7 days. For waters in North America, we can normally provide a report within 48 hours of satellite overpass. Turnaround in other regions of the world, that really depends on the ground stations that are receiving the satellite data, but it's normally a case of days, not weeks. Now, there is absolutely no special training needed to use Blue Water Satellite data. Our written reports are thorough but simple to understand, with the images accompanied by color-coded keys to identify concentration ranges. And using the GeoTIFF files in your ArcGIS or other GIS software requires only a fundamental 5-minute training proficiency in order to use those programs. Our pricing is based on surface acreage, the number of constituents you want us to test for, and frequency of scans, whether going forward or retrieving archived data from the past. Real quick here, before I wrap up my portion of the presentation, I want to take you to give you a look how you can use our data in your GIS software. So what I'm going to do is I'm going to switch over here to, there we go. Okay. This is an image that you saw a bit of earlier. This is Wikiup Reservoir in the state of Oregon. And this is a scan that we did of Wikiup Reservoir for cyanobacteria, for blue-green algae. This is the GeoTIFF file inserted in my actually free QGIS software. But what you're able to do with an image like this is not only see the image as it's being presented to you in the written report, but you could also zoom in and take a much closer look at what the conditions are in a given area. Now, each one of these squares that you see right here as I zoom in, that is an individual sample that we're producing with the Landsat data. Each sample is 30 by 30 meters. And what you're able to do in your QGIS or ArcGIS software is not only see the ranges as represented by the different colors, but also you can click on each pixel, and you can see right here, what that indicates is that pixel I just clicked on, that area of the lake has a concentration level of 29 parts per billion. This red pixel here, 52 parts per billion. This lighter blue pixel, 8 parts per billion. So again, the utility of using our GeoTIFF files in your GIS software is virtually limitless in terms of determining exactly what's happening in your body of water in each exact area. And Nick, I will turn this back over to you for the conclusion of the formal presentation.
Thanks, Jim. We're now going to go over just how HydroLab fits into this whole picture. As we've outlined in previous slides, satellite imaging provides an excellent idea of the health of a water body as a whole. However, detailed sampling with HydroLab sondes is necessary for in-depth analysis of trouble areas. Data on cyanobacteria, phosphorus, and chlorophyll A give an excellent snapshot of the general health of a lake or stream, but sondes are necessary to provide information on other parameters like pH, DO, temperature, and conductivity that round out the story of a problem spot. So as you can see, the two technologies complement each other. Satellite imaging provides the big picture and guides the deployment of HydroLab sondes in what we call smart sampling, taking expensive spot samples only where they are needed. Pairing the two technologies together provides a higher level of data density than either technology alone can provide. By using satellite imaging with grab sampling, you can be confident in your assessment of the entire water body as well as the detailed water structure composition. While it may sound expensive, satellite imaging is a surprisingly economical method of water quality monitoring. There is no set price as the pricing structure is based on the number of acres and constituents measured, desired sampling frequency, the length of your contract, which is set on a month-to-month basis. It is important to note that the larger the water body, the lower the price per acre it takes to measure it. For example, projects 200 to 500 acres may cost $1.20 an acre. However, a project in the 1,000 to 2,000 acre range could cost as little as 50 cents an acre. For extremely large projects, the price drops even further, and those above 50,000 acres can see prices as small as 1 cent per acre. As pricing is tailored to the project at hand, please contact Hawk Hydromet Sales for an accurate quote on your monitoring project. We'd like to thank you for attending today's webinar. Again, if you have any additional questions, you can contact Hawk Hydromet Technical Support, and if you would like any detailed pricing information, you can contact Hawk Hydromet Sales. Thank you and have a great day.